Solaris by Stanisław Lem. Chapter 8. The Monsters. I woke up in the middle of the night to find the light on, and Rhea, crouched at the end of the bed, wrapped in a sheet, her shoulders shaking with silent tears. I called her name and asked her what was wrong, but she only curled up tighter. Still half asleep and barely emerged from the nightmare which had been tormenting me only a moment before, I pulled myself up to a sitting position and shielded my eyes against the glare to look at her. The trembling continued, and I stretched out my arms, but Rhea pushed me away and hid her face. Rhea? Don't talk to me. Rhea, what's the matter? I caught a glimpse of her tear-stained face, contorted with emotion. The big childish tears streamed down her face, glistened in the dimple above her chin, and fell onto the sheet. You don't want me. What are you talking about? I heard. My jaw tightened. Heard what? You don't understand. Yes, I do. You said I wasn't, Rhea. You wanted me to go, and I would. I really would, but I can't. I don't know why. I've tried to go, but I couldn't do it. I'm such a coward. Come on now. I put my arms around her and held her with all my strength. Nothing mattered to me except her. Everything else was meaningless. I kissed her hands, talked, begged, excused myself, and made promise after promise, saying that she had been having some silly, terrible dream. Gradually she grew calmer, and at last she stopped crying, and her eyes glazed, like a woman walking in her sleep. She turned her face away from me. No, she said at last. Be quiet. Don't talk like that. It's no good. You're not the same person anymore. I started to protest, but she went on. No, you don't want me. I knew it before, but I pretended not to notice. I thought perhaps I was imagining everything, but it was true. You've changed. You're not being honest with me. You talk about dreams, but it was you who were dreaming. And it was to do with me. You spoke my name as if it repelled you. Why? Just tell me why. Rhea, my little, I won't have you talking to me like that. Do you hear? I won't let you. I'm not your little anything. I'm not a child. She burst into tears and buried her face in the pillow. I got up. The ventilation hummed quietly. It was cold, and I pulled a dressing gown over my shoulders before sitting next to her and taking her arm. Listen to me. I'm going to tell you something. I'm going to tell you the truth. She pushed herself upright again. I could see the veins throbbing beneath the delicate skin of her neck. My jaw tightened once more. The air seemed to be colder still, and my head was completely empty. The truth, she said. Word of honor? I opened my mouth to speak, but no sound came. Word of honor. It was our special catchphrase. Our old way of making an unconditional promise. Once these words had been spoken, neither of us was permitted to lie, or even to take refuge behind a half-truth. I remembered the period when we used to torture each other in exaggerated striving for sincerity, convinced that this ingenuous honesty was the precondition of our relationship. Word of honor, Rhea, I answered gravely, and she waited for me to continue. You have changed too. We all change, but that is not what I wanted to say. For some reason that neither of us understands, it seems that you are forced to stay near me, and that's fine with me because I can't leave you either. No, Kris, the change is not in you, Rhea whispered. It's me. Something is wrong. Perhaps it has to do with the accident? She looked at the dark, empty rectangle of the door. The previous evening, I had removed the shattered remains. A new one would have to be fitted. Another thought struck me. Have you been managing to sleep? I don't know. What do you mean? I have dreams. I don't know whether they really are dreams. Perhaps I'm ill. I lie there and think and... What? I have strange thoughts. I don't know where they come from. It took all my self-control to steady my voice and tell her to go on, and I found myself tensing for her answer, as if for a blow in the face. They are thoughts. She shook her head helplessly, all around me. I don't understand. I get a feeling as if they were not from inside myself, but somewhere further away. I can't explain it. Can't put words to it. I broke in almost involuntarily. It must be some kind of dream. Then back in control again. And now we put the light out and we forget our problems until morning. Tomorrow, we can invent some new ones if you like. Okay? She pressed the switch, and darkness fell between us. Stretched out on the bed, I felt her warm breathing beside me and put my arms round her. Harder, she whispered, and then, after a long pause, Kris. What? I love you. I almost screamed. In the red morning, the sun-swollen disk was rising over the horizon. An envelope lay in the doorway, and I tore it open. I could hear Rhea humming to herself in the bath. And from time to time she looked into the room, and I would see her face half hidden by her wet hair. I went to the window and read. Kelvin, things are looking up. Sartorius has decided that it may be possible to use some form of energy to destabilize the neutrino structure. He wants to examine some phi plasma in orbit. He suggests that you make a reconnaissance flight and take a certain quantity of plasma in the capsule. It's up to you, but let me know what you decide. I have no opinion. I feel as if I no longer have anything. If I am more in favor of your going, it's because we would at least be making some show of progress. Otherwise, we can only envy G. Snow. P.S. All I ask is for you to stay outside the cabin. You can call me on the video phone. I felt a stir of apprehension as I read the letter and went over it again carefully before tearing it up and throwing the pieces into the disposal unit. I went through the same terrible charade that I had begun the previous day and made up a story for Rhea's benefit. She did not notice the deception, and when I told her that I had to make an inspection and suggested that she come with me, she was delighted. We stopped at the kitchen for breakfast. Rhea ate very little, and then made for the library. Before venturing on the mission suggested by Sartorius, I wanted to glance through the literature dealing with magnetic fields and neutrino structures. I did not yet have any clear idea of how I would set about it, but I had made up my mind to make an independent check on Sartorius's activities. Not that I would prevent Snow and Sartorius from liberating themselves when the Annihilator was completed. I meant to take Rhea out of the station and wait for the conclusion of the operation in the cabin of an aircraft. I set to work with the automatic librarian. Sometimes it answered my queries by ejecting a card with a laconic inscription, "Not on file." Sometimes it practically submerged me under such a spate of specialist physics textbooks that I hesitated to use its advice. Yet, I had no desire to leave the big circular chamber. I felt at ease in my egg, among the rows of cabinets crammed with tape and microfilm. Situated right at the center of the station, the library had no windows and made me feel relaxed, in spite of finding my researches held up. Wandering across the vast room, I stopped at a set of shelves as high as the ceiling and holding about 600 volumes, all classics on the history of Solaris, starting with the 9 volumes of Guise's monumental and already relatively obsolescent monograph. Display, for its own sake, was improbable in these surroundings. The collection was a respectful tribute to the memory of the pioneers. I took down the massive volumes of Guise and sat leafing through them. Rhea had also located some reading matter. Looking over her shoulder, I saw that she had picked one of the many books brought out by the first expedition, the Interplanetary Cookery Book, which could have been the personal property of Guise himself. She was poring over the recipes adapted to the arduous conditions of interstellar flight. I said nothing and returned to the book resting on my knees. Solaris, 10 Years of Exploration, had appeared as volumes 4 to 12 on the Solariana collection, whose most recent editions were numbered in the thousands. Guise was an unemotional man, but then in the study of Solaris emotion is a hindrance to the explorer. Imagination and premature theorizing are positive disadvantages in approaching a planet where, as has become clear, anything is possible. It is almost certain that the unlikely descriptions of the plasmatic metamorphosis of the ocean are faithful accounts of the phenomena observed, although these descriptions are unverifiable, since the ocean seldom repeats itself. The freakish character and gigantic scale of these phenomena go too far outside the experience of man to be grasped by anybody observing them for the first time, and who would consider analogous occurrences as sports of nature, accidental manifestations of blind forces if he saw them on a reduced scale, say in a mud volcano on Earth. Genius and mediocrity alike are dumbfounded by the teeming diversity of the oceanic formations of Solaris. No man has ever become genuinely conversant with them. Guise was by no means a mediocrity, but nor was he a genius. He was a scholarly classifier, the type whose compulsive application to their work utterly divorces them from the pressures of everyday life. Guise devised a plain descriptive terminology, supplemented by terms of his own invention. And although these were inadequate and sometimes clumsy, it has to be admitted that no semantic system is as yet available to illustrate the behavior of the ocean. The tree mountains, extensors, fungoids, mimoids, Symmetriads, asymmetriads, vertebrates, and agalus are artificial, linguistically awkward terms, but they do give some impression of Solaris to anyone who has only seen the planet in blurred photographs and incomplete films. The fact is that, in spite of his cautious nature, the scrupulous geese more than once jumped to premature conclusions. Even when on their guard, human beings inevitably theorize. Geese, who thought himself immune to temptation, decided that the extensors came into the category of basic forms. He compared them to accumulations of giant waves, similar to the tidal movements of our Terran oceans. In the first edition of his work, we find them originally named as tides. This geocentrism might be considered amusing if it did not underline the dilemma in which he found himself. As soon as the question of comparisons with Earth arises, it must be understood that the extensors are formations that dwarf the Grand Canyon, that they are produced in a substance which externally resembles a yeasty colloid. During this fantastic fermentation, the yeast sets into festoons of starched open work lace, some experts referred to as ossified tumors. And that deeper down, the substance becomes increasingly resistant, like a tensed muscle, which 50 feet below the surface is as hard as rock, but retains its flexibility. The extensor appears to be an independent creation, stretching for miles between membranous walls swollen with ossified growths, like some colossal python, which after swallowing a mountain is sluggishly digesting the meal, while a slow shudder occasionally ripples along its creeping body. The extensor only looks like a lethargic reptile from overhead. At close quarters, when the two canyon walls loom hundreds of yards above the exploring aircraft, it can be seen that this inflated cylinder, reaching from one side of the horizon to the other, is bewilderingly alive with movement. First, you notice the continual rotating motion of a grayish-green, oily sludge, which reflects blinding sunlight. But skimming just above the back of the python, the ravine sheltering the extensor now resembles the sides of a geological fault. You realize that the motion is, in fact, far more complex and consists of concentric fluctuations traversed by darker currents. Occasionally, this mantle turns into a shining crust that reflects sky and clouds, and then is riddled by explosive eruptions of the internal gases and fluids. The observer slowly realizes that he is looking at the guiding forces that are thrusting outward and upward the two gradually crystallizing gelatinous walls. Science does not accept the obvious without further proof, however, and virulent controversies have reverberated down the years on the key question of the exact sequence of events in the interior of the extensors that furrow the vast living ocean in their millions. Various organic functions have been ascribed to the extensors. Some experts have argued that their purpose is the transformation of matter. Others suggested respiratory processes. Still others claim that they conveyed alimentary materials. An infinite variety of hypotheses now molder in library basements, eliminated by ingenious, sometimes dangerous, experiments. Today, the scientists will go no further than to refer to the extensors as relatively simple, stable formations, whose duration is measurable in weeks, an exceptional characteristic among the recorded phenomena of the planet. The mimoid formations are considerably more complex and bizarre, and elicit a more vehement response from the observer. An instinctive response, I mean. It can be stated without exaggeration that Gies fell in love with the mimoids and was soon devoting all his time to them. For the rest of his life, he studied and described them and brought all his ingenuity to bear on defining their nature. The name he gave them indicates their most astonishing characteristic: the imitation of objects, near or far, external to the ocean itself. Concealed at first beneath the ocean surface, a large flattened disk appears, ragged, with a tar-like coating. After a few hours, it begins to separate into flat sheets, which rise slowly. The observer now becomes a spectator at what looks like a fight to the death, as massed ranks of waves converge from all directions, like contorted fleshy mouths, which snap greedily around the tattered, fluttering leaf, then plunge into the depths. As each ring of waves breaks and sinks, the fall of this mass of hundreds of thousands of tons is accompanied for an instant by a viscous rumbling, an immense thunderclap. The tarry leaf is overwhelmed, battered, and torn apart. With every fresh assault, circular fragments scatter and drift, like feebly fluttering wings below the ocean surface. They bunch into pear-shaped clusters or long strings, merge and rise again, and drag with them an undertow of coagulated shred of the base of the primal disk. The encircling waves continue to break around the steadily expanding crater. This phenomenon may persist for a day or linger on for a month, and sometimes there are no further developments. The conscientious Gies dubbed this first variation a stillbirth, convinced that each of these upheavals aspired towards an ultimate condition. The major mimoid, like a polyp colony, only covering an area greater than a town, of pale outcroppings, with the faculty of imitating foreign bodies. Uvens, on the other hand, saw this final stage as constituting a degeneration or necrosis, according to him. The appearance of the copies corresponded to a localized dissipation of the life energies of the ocean, which was no longer in control of the original forms it created. Gies would not abandon his account of the various phases of the process as a sustained progression towards perfection, with a conviction which is particularly surprising of mind in advancing the most trivial hypotheses on the other creations of the ocean. Normally, he had all the boldness of an ant crawling up a glacier. Viewed from above, the mimoid resembles a town, an illusion produced by our compulsion to superimpose analogies with what we know. When the sky is clear, a shimmering heat haze covers the plain structures of the clustered polyps, surmounted by membranous palisades. The first cloud passing overhead wakens the mimoid. All the outcrops suddenly sprout new shoots. Then the mass of polyps ejects a thick tegument, which dilates, puffs out, changes color, and in the space of a few minutes has produced an astonishing imitation of the volutes of a cloud. The enormous object casts a reddish shadow over the mimoid, whose peaks ripple and bend together, always in the opposite direction to the movement of the real cloud. I imagine that Gies would have been ready to give his right hand to discover what made the mimoids behave in this way, but these isolated productions are nothing in comparison to the frantic activity the mimoid displays when stimulated by objects of human origin. The reproduction process embraces every object inside a radius of 8 or 9 miles. Usually, the facsimile is an enlargement of the original, whose forms are sometimes only roughly copied. The reproduction of machines, in particular, elicits simplifications that might be considered grotesque, practically caricatures. The copy is always modeled in the same colorless tegument, which hovers above the outcrops, linked to its base by flimsy umbilical cords. It slides, creeps, curls back on itself, shrinks or swells, and finally assumes the most complicated forms. An aircraft, a net, or a pole are all reproduced at the same speed. The mimoid is not stimulated by human beings themselves, and in fact, it does not react to any living matter, and has never copied, for example, the plants imported for experimental purposes. On the other hand, it will readily reproduce a puppet or a doll, a carving of a dog, or a tree sculpted in any material. The observer must bear in mind that the obedience of the mimoid does not constitute evidence of cooperation, since it is not consistent. The most highly evolved mimoid has its off days, when it lives in slow motion or its pulsation weakens. This pulsation is invisible to the naked eye and was only discovered after close examination of rapid motion film of the mimoid, which revealed that each beat took 2 hours. During these off days, it is easy to explore the mimoid, especially if it is old, for the base anchored in the ocean, like the protuberances growing out of it, is relatively solid and provides a firm footing for a man. It is equally possible to remain inside the mimoid during periods of activity, except that visibility is close to nil because of the whitish colloidal dust continually emitted through tears in the tegument above. In any case, at close range, it is impossible to distinguish what forms the tegument. On account of their vast size, the smallest copy is the size of a mountain. In addition, a thick layer of colloidal snow quickly covers the base of the mimoid. This spongy carpet takes several hours to solidify. The frozen crust will take the weight of a man, though its composition is much lighter than pumice stone. The problem is that without special equipment, there is a risk of being lost in the maze of tangled structures and crevices, sometimes reminiscent of jumbled colonnades, sometimes of petrified geysers. Even in daylight, it is easy to lose one's direction, for the sun's rays cannot pierce the white ceiling ejected into the atmosphere by the imitative explosions. On gala days, for the scientist as well as the mimoid, an unforgettable spectacle develops as the mimoid goes into hyperproduction and performs wild flights of fancy. It plays variations on the theme of a given object and embroiders formal extensions that amuse it for hours on end, to the delight of the non-figurative artist and the despair of the scientist, who is at a loss to grasp any common theme in the performance. The mimoid can produce primitive simplifications, but is just as likely to indulge in Baroque deviations, paroxysms of extravagant brilliance. Old mimoids tend to manufacture extremely comic forms. Looking at the photographs, I have never been moved to laughter. The riddle they set is too disquieting to be funny. During the early years of exploration, the scientists literally threw themselves upon the mimoids, which were spoken of as open windows on the ocean, and the best opportunity to establish the hoped-for contact between the two civilizations. They were soon forced to admit that there was not the slightest prospect of communication. and that the entire process began and ended with the reproduction of forms. The mimoids were a dead end, giving way to the temptations of a latent anthropomorphism or zoomorphism. There were many schools of thought which saw various other oceanic formations as sensory organs, even as limbs, which was how experts like Martens and Econai classified geese as vertebrates and aegilis for a while. Anyone who's rash enough to see protuberances that reach as far as 2 miles into the atmosphere as limbs might just as well claim that earthquakes are the gymnastics of the Earth's crust. 300 chapters of Geese Catalogue, the standard formations which occur on the surface of the living ocean and which can be seen in dozens, even hundreds, in the course of any day. The Symmetriads, to continue using the terminology and definitions of the Geese school, are the least human formations, which is to say that they bear no resemblance whatsoever to anything on Earth. By the time the Symmetriads were being investigated, it was already clear that the ocean was not aggressive and that its plasmatic eddies would not swallow anyone but the most foolhardy explorer. Of course, I am not including accidents resulting from mechanical failures. It is possible to fly in complete safety from one part to another of the cylindrical body of an extensor or of the vertebrates, Jacob's ladders oscillating among the clouds. The plasma retreats at the speed of sound in the planet's atmosphere to make way for any foreign body. Deep funnels will open even beneath the surface of the ocean at a prodigious expenditure of energy, calculated by Scriabin at about 10 to the 19th ergs. Nevertheless, the first venture into the interior of a Symmetriad was undertaken with the utmost caution and discipline, and involved a host of what turned out to be unnecessary safety measures. Every schoolboy on Earth knows the names of these pioneers. It is not their nightmare appearance that makes the gigantic Symmetriad formations dangerous, but the total instability and capriciousness of their structure, in which even the laws of physics do not hold. The theory that the living ocean is endowed with intelligence has found its firmest adherents among those scientists who have ventured into their unpredictable depths. The birth of a Symmetriad comes like a sudden eruption. About an hour beforehand, an area of tens of square miles of ocean vitrifies and begins to shine. It remains fluid, and there is no alteration in the rhythm of the waves. Occasionally, the phenomenon of vitrification occurs in the neighborhood of the funnel, left by an aegilis. The gleaming sheath of the ocean heaves upwards to form a vast ball that reflects sky, sun, clouds, and the entire horizon in a medley of changing, variegated images. Diffracted light creates a kaleidoscopic play of color. The effects of light on a Symmetriad are especially striking during the blue day and the red sunset. The planet appears to be giving birth to a twin that increases in volume from one moment to the next. The immense flaming globe has scarcely reached its maximum expansion above the ocean when it bursts at the summit and cracks vertically. It is not breaking up. This is the second phase, which goes under the clumsy name of the floral calyx phase and lasts only a few seconds. The membranous arches soaring into the sky now fold inwards, emerge to produce a thick-set trunk enclosing a scene of teeming activity. At the center of the trunk, which was explored for the first time by the 70-man Hamalai expedition, a process of polycrystallization on a giant scale erects an axis commonly referred to as the backbone, a term which I consider ill-chosen. The mind-bending architecture of this central pillar is held in place by vertical shafts of a gelatinous, almost liquid consistency, constantly gushing upwards out of wide crevasses. Meanwhile, the entire trunk is surrounded by a belt of snowy foam, seething with great bubbles of gas, and the whole process is accompanied by a perpetual dull roar of sound. From the center towards the periphery, powerful buttresses spin out and are coated with streams of ductile matter, rising out of the ocean depths. Simultaneously, the gelatinous geysers are converted into mobile columns that proceed to extrude tendrils that reach out in clusters towards points rigorously predetermined by the overall dynamics of the entire structure. They call to mind the gills of an embryo, except that they are revolving at fantastic speed and ooze trickles of pinkish blood and a dark green secretion. The Symmetriad now begins to display its most exotic characteristic, the property of illustrating, sometimes contradicting, various laws of physics. Bear in mind that no two Symmetriads are alike, and that the geometry of each one is a unique invention of the living ocean. The interior of the Symmetriad becomes a factory for the production of monumental machines, as these constructs are sometimes called, although they resemble no machine which it is within the power of mankind to build. The designation is applied because all this activity has finite ends, and is therefore, in some sense, mechanical. When the geysers of ocean matter have solidified into pillars, or into three-dimensional networks of galleries and passages, and the membranes are set into inextricable pattern of stories, panels, and vaults, the Symmetriad justifies its name, for the entire structure is divided into two segments, each mirroring the other, to the most infinitesimal detail. After 20 or 30 minutes, when the axis may have tilted as much as 8 to 10 degrees from the horizontal, the giant begins slowly to subside. Symmetriads vary in size, but as the base begins to submerge, even the smallest reach a height of half a mile and are visible from miles away. At last, the structure stabilizes itself, and the partly submerged Symmetriad ceases its activity. It is now possible to explore it in complete safety by making an entry near the summit, through one of many siphons which emerge from the dome. The completed Symmetriad represents a spatial analogue of some transcendental equation. It is commonplace that any equation can be expressed in the figurative language of non-Euclidean geometry and represented in 3 dimensions. This interpretation relates the Symmetriad to Lobachevsky's cones and Riemann's negative curves, although its unimaginable complexity makes the relationship highly tenuous. The eventual form occupies an area of several cubic miles and extends far beyond our whole system of mathematics. In addition, this extension is 4-dimensional, for the fundamental terms of the equations use a temporal symbolism expressed in the internal changes over a given period. It would be only natural, clearly, to suppose that the Symmetriad is a computer of the living ocean, performing calculations for a purpose that we are not able to grasp. This was Friedman's theory, now generally discounted. The hypothesis was a tempting one, but it proved impossible to sustain the concept that the living ocean examined problems of matter, the cosmos, and existence through the medium of titanic eruptions, in which every particle had an indispensable function as a controlled element in an analytical system of infinite purity. In fact, numerous phenomena contradict this oversimplified, some say childishly naive concept. Any number of attempts have been made to transpose and illustrate the Symmetriad, and Averian's demonstration was particularly well received. Let us imagine, he said, an edifice dating from the great days of Babylon, but built of some living, sensitive substance with the capacity to evolve. The architectonics of this edifice passes through a series of phases, and we see it adopt the forms of a Greek, then of a Roman building. The columns sprout like branches and become narrower. The roof grows lighter, rises, curves. The arch describes an abrupt parabola, then breaks down into an arrow shape. The Gothic is born, comes to maturity, and gives way in time to new forms. Austerity of line gives way to a riot of exploding lines and shapes, and the Baroque runs wild. If the progression continues and the successive mutations are to be seen as stages in the life of an evolving organism, we finally arrive at the architecture of the space age, and perhaps, too, at some understanding of the Symmetriad. Unfortunately, no matter how this demonstration may be expanded and improved, there have been attempts to visualize it with the aid of models and films. The comparison remains superficial. It is evasive and illusory, and sidesteps the central fact that the Symmetriad is quite unlike anything Earth has ever produced. The human mind is only capable of absorbing a few things at a time. We see what is taking place in front of us in the here and now, and cannot envisage simultaneously a succession of processes, no matter how integrated and complementary. Our faculties of perception are consequently limited, even as regards fairly simple phenomena. The fate of a single man can be rich with significance, that of a few hundred less so, but the history of thousands and millions of men does not mean anything at all, in any adequate sense of the word. The Symmetriad is a billion rather, raised to the power of n. It is incomprehensible. We pass through vast halls, each with a capacity of 10 Kronecker units, and creep like so many ants, clinging to the folds of breathing vaults and craning to watch the flight of soaring girders, opalescent in the glare of searchlights, and elastic domes which crisscross and balance each other unerringly. The perfection of a moment, since everything here passes and fades. The essence of this architecture is movement synchronized towards a precise objective. We observe a fraction of the process, like hearing the vibration of a single string in an orchestra of supergiants. We know, but cannot grasp, that above and below, beyond the limits of perception or imagination, thousands and millions of simultaneous transformations are at work. Interlinked, like a musical score, by mathematical counterpoint. It has been described as a symphony in geometry, but we lack the ears to hear it. Only a long-distance view would reveal the entire process, but the outer covering of the Symmetriad conceals the colossal inner matrix, where creation is unceasing. The created becomes the creator, and absolutely identical twins are born at opposite poles, separated by towering structures and miles of distance. The symphony creates itself and writes its own conclusion, which is terrible to watch. Every observer feels like a spectator at a tragedy or a public massacre, when after 2 or 3 hours, never longer, the living ocean stages its assault. The polished surface of the ocean swirls and crumples. The desiccated foam liquefies again, beginning to seethe, and legions of waves pour inwards from every point of the horizon. their gaping mouths far more massive than the greedy lips that surround the embryonic mimoid. The submerged base of the Symmetriad is compressed, and the colossus rises as if on the point of being shot out of the planet's gravitational pull. The upper layers of the ocean redouble their activity, and the waves surge higher and higher to lick against the sides of the Symmetriad. They envelope it, harden, and plug the orifices, but their attack is nothing compared to the scene in the interior. First, the process of creation freezes momentarily. Then there is panic. The smooth interpenetration of moving forms and the harmonious play of planes and lines accelerates. And the impression is inescapable that the Symmetriad is hurrying to complete some task in the face of danger. The awe inspired by the metamorphosis and dynamics of the Symmetriad intensifies as the proud sweep of the domes falters, vaults sag and droop, and wrong notes, incomplete, mangled forms make their appearance. A powerful moaning roar issues from the invisible depths like a sigh of agony, reverberates through the narrow funnels, and booms through the collapsing domes. In spite of the growing destructive violence of these convulsions, the spectator is rooted to the spot. Only the force of the hurricane, streaming out of the depths and howling through the thousands of galleries, keeps the great structure erect. Soon it subsides and starts to disintegrate. There are final flutterings, contortions, and blind random spasms. Gnawed and undermined, the giant sinks slowly and disappears, and the space where it stood is covered with whirlpools of foam. So what does all this mean?